In this video, we are going to look at an example on wall of death. If you haven't watched my videos on Newton's laws and uniform circular motion, I'll put the link up there. A motorcyclist is driving on the wall of death, which is a cylinder with vertical wall, and the radius of the wall of death is 6 meters. The coefficient of static friction between the tires and the wall is 0.2. What is the minimum speed the motorcyclist should go so the tires don't slide? Let's sketch a diagram. So the wall is a vertical wall, and the car would be driving around like this. What are the forces acting on the car? There is gravity force that is pointing downward, and the static friction would be preventing the car to going downward. So static friction is pointing upward. And we want to find the minimum speed, which means the static friction is at its maximum. And the car is in contact with the wall, so there is normal force that is perpendicular to the surface. Now let's define x is positive into the circle and y is positive upward. We want to find the minimum speed. Let's use Newton's second law in the y direction. F net in y equals to mass times acceleration in y. And since the car is not going up or down, so acceleration in y is 0. And F net in y, there is the maximum static friction and gravity force that is in the negative direction. And this equals to 0. And maximum static friction is the coefficient times the normal force. And this equals to gravity force, mass times g. Then we isolate for the normal force. It equals to the gravity force divided by the coefficient. And let's call this equation 1. Now let's look at the x component. F net in x equals to mass times the centripetal acceleration. Centripetal acceleration equals to the speed squared over r. In this example, there's only one force pointing in the radial direction, that is the normal force. So normal force equals to mv squared over r. And that is our equation 2. Then we can equate equation 1 with equation 2. We get mg over the coefficient equals to mv squared over r. Mass can be cancelled out, so the minimum speed squared must be the radius times gravitational acceleration over the coefficient. We have all the knowns here. R is 6 meters. G is the constant 9.8. And the coefficient of static friction is 0.2. Then you plug in the numbers and take the square root to find that the minimum speed, so that the car doesn't slide downward, is 17.15 meters per second. Or you can convert it into kilometers per hour, which is 61.73 kilometers per hour. So that is the minimum speed you need to go if you drive in a wall of death with radius of 6 meters. And that is the end of the video. If you like my videos, please like and subscribe, and I'll see you in the next video.